Dear friends, today I will discuss some questions from NTA-UGC-NET December 2019 Electronic Science, that is paper 2 and the questions are based mainly from Unit 1 and Unit 2 of the syllabus. Fine. Question number 1. In X-ray lithography, if S is the size of the X-ray source, G is the gap between wafer and mask, and D is the distance between the source and the mask, then the blur is. Options are, option 1 is D by GS, option 2 is GS by D, option 3 is D minus GS, and option 4 is G minus D whole divided by S. And the answer is option number 2, that is GS divided by D. Fine. So for this, for the explanation of this answer, please take a look at the below drawing or the picture. Okay, so you can see here, this is the source, that is S, and D, this is the distance between the source and the mask. Okay, and here this is the mask. Fine. This distance is G, and G is the gap between wafer and mask, because this is the wafer. Okay, this lining is the wafer and this lining is the mask. This is the gap. The gap is G. Okay. So you can just remember from this picture that blur equal to, we are denoting blur by sigma. Okay, and this blur, the formula of this blur is SG divided by D, or we can write it like GS whole divided by D. Okay, and so what is a blur? The literal meaning of blur is, this is the, what is blur? That this is the, blur is something we can say that a thing that can't be seen or heard clearly. If there is a blur, we can't see things properly, or we can, yeah. If there is a blur, we can't see things properly, or we can't hear things properly. Fine. Next, question number 2. Arrange the following in terms of decreasing order of their propagation delay. The options are A. RTL, B. ECL, C. TTL, and D. CMOS. Fine. And we can say that the correct sequence of decreasing order of propagation delay is, the options are, option 1 is ADCB, option 2 is ABDC, option 3 is DACB, and option 4 is BDCL. And the correct option is option number 3, that is DACB. Now, in the explanation part, we can write this order as follows, right? Like CMOS greater than RTL, greater than TTL, and greater than TTL is greater than ECL. Okay? Where, what is CMOS? CMOS is complementary metal oxide semiconductor. It has propagation delay 70 nanoseconds. And this CMOS uses complementary and symmetrical pairs of P-type and N-type MOSFETs for logic functions. Just to remember. Fine. What is RTL? RTL is resistor transistor logic. What is a TTL? It is transistor logic. Transistors perform both the logic and amplifying function here. Fine. And it has a propagation delay of 10 nanoseconds. Then ECL. ECL is emitter coupled logic. Fine. And it has a propagation delay of 1 nanoseconds. Fine. Next I will go to question number 3. Which of the following components are used for bias compensation in transistor circuits? Fine. Option number 1 is thermistors only. Option number 2 is rectifying diodes only. Option 3 is both thermistors and rectifying diodes. Option 4 is a combination of resistors. Fine. Answer is, correct option is option number 3, that is both thermistors and rectifying diodes. Fine. In the explanation part, we can read, bias compensation use sensitive devices such as diode, transistors, thermistors, sensistors, etc. to maintain operating point constant. Okay, just remember these things. Fine. Next I will go to question number 4. Question number 4 says some analog devices are listed below. A. Transistor in CE configuration. B. Transistor in CB configuration. C. Transistor in CC configuration. And D is op-amp. Right? Select the right option about the current gain of these devices in descending order. And the correct answer will be option number 4, that is DCAB. Now in the explanation part I can write like op-amp greater than CC configuration, greater than CE configuration, greater than CB configuration. Okay, just remember these things. Fine. Next, question number 5. The Eber-Small equation for the emitter current is, you can just read these options carefully. Option A, A11, okay, into exponential within brackets V divided by Vt, bracket closes, minus 1, okay, plus A12, okay, into exponential within brackets Vc by Vt, bracket closes, minus 1, bracket closes, the square bracket closes. And you can read these options carefully. Fine. Okay. Just take a look. Okay. And I can say, just take a look at the option 1, that this first part, that is small a 11 into exponential within brackets V divided by Vt, okay, minus 1, and the square bracket also closes. This part is actually IDE, that is current. And the second part, that is A12 whole into exponential within brackets Vc by Vt, minus 1, square bracket closes, and this refers to IDC, current part. Okay, this current is IDE current and the second part current is IDC current. Fine. So you just take a careful look at the options. Okay, just take a look. Okay. If you can see, if you see carefully, only some parameters are changing in option 1, 2 and 3. Parameters and signs are changing. Here is minus, this is plus, this is Vc by Vt, this is V by Vt, like this. And our answer is option A. Fine. Option 4 is also, you can take a look, that A11 into exponential Vc by Vt whole into plus 1, sorry, just a minute. Option 4 is A11 within square brackets we have exponential Vc by Vt, that is within brackets plus 1 plus A12 whole into exponential Ve divided by Vt, this plus 1, square bracket closes. Okay. The answer is, the explanation for the answer is like, transistors are measured using Eber-Moll's model parameters, where IDE equal to ISC whole into exponentials of VBE divided by Vt minus, that means the bracket closes, minus 1, and then the square bracket also closes. Similarly, IDC equal to ISC whole into exponential VBC divided by Vt whole minus 1, square bracket closes. Fine. So you can go through this part more detail in the book, but for time being you can remember these things. Fine. Next, Match list 1 and list 2. List 1 is about the characteristics and list 2 is about the logic family. So, we can, I am just telling you the matches here. From list 1, bit A matches with bit 4. That is, we can say improved noise immunity or increased complexity is for CMOS. Next, B. Fastest of all logic families or greater power consumption is for ECL, emitter coupled logic. Then C is most popular logic family or moderate packing density. This is for TTL, transistor logic. And D is simplest to fabricate or susceptible to static charge doses. This is for MOS, that is simple metal oxide semiconductor. Okay, so choose the correct answer. The correct option is option 1 that I have discussed earlier. Fine, that is A bit 4, B bit 2, C bit 1 and 2 bit 3. Okay, so this way I have completed 6 questions from Unit 1 and Unit 2 of the question of Electronic Science December 2019. Fine. In the next session, I will discuss some more questions. Okay. Till then, please go through my video. Please compliment or comment in the comment section. Share the video and please subscribe my channel. Thank you.